Great. So welcome everybody to this short lesson of physics. We want to learn about the concept of change, and more so, or more specifically, we want to understand transformation of energy. So the objective of this lesson is for us to be able to describe how kinetic energy can be transformed into electrical energy. All right? This on the IB physics syllabus is topic 11.1, and there are some key terms that you need to be aware of. This would follow from the work we did previously. So these key terms are such as induced EMF, magnetic rate, magnetic flux, we've got solenoid, loop area, and the others. So to start it off in this lesson, we have an experimental demonstration which is going to help us understand why change is important in physics, or what are some of the important consequences of change in physics. And so basically we will make observations and conclusions on the effects of change by using an experimental setup. So we're talking about transformation of kinetic energy. So here I've got a magnet, and we're going to make the magnet move relative to a solenoid, all right? And so the kind of change I will cause is basically causing some relative motion between these two, right? In order to, so this is actually kinetic energy changing, maybe increasing, staying constant at some point. So this is some form of change. Now, we want to see what is the effect of these changes on the electrical energy that might be created in the wires, following from our previous lesson. So in order for us to see or study the effect of the change, we have connected the solenoid to a galvanometer, which is a very sensitive equipment for measuring small voltages and currents. And we also have a Pascal sensor, which can enable us to read on a computer screen even the slightest of induced EMFs that we generate from the changes we cause, right? And so we're going to start off. That's a brief introduction of what we have here. And so I'm going to perform different changes, such as the first one would be moving the magnet into the solenoid with increasing speed, moving it out, all right? And then also moving it across, all right? Across the solenoid, across the plane of the solenoid. And then we will see what effect does this change have on the electrical energy within the wires, within the solenoid. So I'm going to start our computer, and you can see the sensor, the voltage sensor, is ready to record the effects of any electrical energy, which at the moment is very close to zero. So just a tiny bit because of the zero error of the sensor. So I'm going to start with the first one, and I would like you to make two observations. Observe what happens to the galvanometer pointer, and also observe what happens at the screen for the sensor. So here we go. I'm going to start slowly. So I stay inside the solenoid and then move out slowly again. All right? Now the next change I'm going to introduce is moving quite fast. So there you go. You can see the screen, there's a higher amplitude of the pulse, and then comes back to zero if I don't make any change. And then I'm going to take this out very fast. So you can also see from the screen is that you get an amplitude that is even larger, but now on a different direction, which is almost the same as what we would observe in the galvanometer. Now I'm going to try and move in a different way. So this is across the solenoid slowly and then faster. So slowly. You can see there's very little, almost zero. Now the most intriguing thing is that if I'm not causing any change, we don't see anything. Then I'm going to now move very fast. So again, you can see comparatively, we almost see no electrical energy, no representation of the electrical energy based on the voltage when we look at the graph, which is also the same as what the needle is going to tell us. So, what are we saying there? That if we are changing the magnetic field, or how fast the magnet moves relative to the solenoid, we actually generate a form of electrical energy, and according to what we can see, we actually generate some sort of recorded EMF, all right, as we can see on the screen. If we don't produce any change, then we don't see any kind of electrical energy being generated by any charge. So now in real life, does this tell us something about, for example, if we think about hydroelectric power and dams, is there something that we can think about based on this? Why do we need to have dams? Why do the dams need to have lots of water? Why is it sometimes that when the water is at a lower level, then we don't get enough power and the companies start rationing our power? So these are the things that we can think about to relate to what we've actually done today, right? So there are a number of factors that are here, and in the next lesson, in the next video, we will find a way that includes mathematics, that combines all these factors that we are seeing, including how we are moving the magnet, how fast we are moving the magnet. There has to be a way, a mathematical way, that we can relate all these things, all these changes, to the electrical energy that we're producing. Thanks for watching the video. See you next time.